shit. That's what I'm talking about.
Wait!
Okay, now, from the beginning.
Okay, I think this is working. I get a thumbs up, this is a good sign. So this is going to be a session which is an introduction to scriptable render pipelines. This is a really big topic that we're actually adding into Unity very, very soon. And this session's kind of going to be what I call tip of the spear session, where I basically talk about the fundamentals of the feature and how you would use it, why you would use it, why we're even adding it into Unity. That's a pretty big question that a lot of people ask, and sort of how to get set up with it in that way. So it's a lot of kind of beginner type stuff to the feature and how you can then use it in production, in your projects. My name is Andy Touch. I work at Unity, and I'm a global content evangelist. My family has no idea what that is. They think I'm being spied on. Okay, so I'm a global content evangelist. So a lot of what I do is I use a lot of features at Unity internally, build demos, build content, and then go and teach people and show people how they can make games using Unity, or non-games as well, and how they can best use these features in the future. So the talk topics I'm going to cover is, what is a scriptable render pipeline? That's a pretty big question. A lot of people sort of know the answer to, or they've seen the keynote, or they see some blog posts. What scriptable render pipelines are going to be available that we're going to share, and how you can sort of begin to create your own scriptable render pipelines. How to get started with using it. So then I'm going to switch to the editor and show you actually how to set it up directly in the editor, because I like to show things very visual and what you click and where you put assets. And the advantages, trade-offs of using the lightweight render pipeline. That's one of the scriptable render pipelines we're building at Unity and sharing. So I'm going to show you how to set it up and kind of how you can make the most of it. And if I have time, which I think I should do because I did this session this morning and had enough time, I'll also show you a couple of neat features that are in the HD render pipeline as well. So a lot of it is about trade-offs, why the fundamentals of scriptable render pipelines, and also some editor demos to show kind of how they work and some benefits. Is that okay with everyone? Lovely. So the main question is, what is a scriptable render pipeline? You're going to see this a lot, and it's mentioned in our keynote that we did at GDC recently, a few days ago. It's in a lot of blog posts, tutorials, and it's going to be a huge element of a lot of the future of Unity, and especially in terms of graphics. And what we're doing is we're configuring and performing rendering in Unity controlled from a C# script. A lot of people have asked us, hey, we want to be able to modify elements or build our own workflows or build our own systems in Unity, or modify Unity to sort of create what we want to create. People don't generally create the same game in Unity. They create everything from a match 3 game, 2D match 3 game on Android, low device, to VR, to AR, to mobile, all sorts of different visual styles, from realistic to like toon PBR, toon shading, I mean. We have all these different sort of graphical choices, and a lot of people want to configure how our renderer pipeline works best for performance and to expose new things. So a prime example of this is Playdead. They created a game called Inside in Unity, and they previously made Limbo as well, which a lot of people also know. And what they did is they basically sort of customized Unity's rendering system to be able to do some unique, interesting effects, especially with lighting. Now, the trouble with customizing the source is that when we release a new version of Unity, then they're kind of given like, oh, okay, we're now sort of branch. We've got to come back in. That's going to be troublesome. So what we've actually done is we've taken Unity's render pipeline, exposed various hooks into the C++ of it. That's accessible from C#. So you can write a C# script that hooks into various things, such as the rendering paths, skybox, all sorts of different things that build up your end render. So a very high-level overview of render pipeline would be this. This is taken from our docs. And you would have your camera rendering, which in order would go through and render different things. So you have depth texture, lighting, opaque objects, opaque image effects, skybox. This is basically the stack that goes through from the beginning of the frame to sort of the first thing drawn to the last thing that's drawn. And what we're doing is we're basically opening this up so people can then, in C# hook into various elements. You know, you don't have a skybox in your game, so you don't want to render it. So you just remove skybox from your rendering and things like that. So we're really trying to open up lots of different hooks that you can then manipulate. So a good example of this is when people sort of begin to create a game, they factor in a lot of technical elements. what type of game they're making and what they need to achieve with it. So in this example, a realistic first-person shooter for high-end desktop and consoles has certain considerations, such as it requires global illumination, reflections, like planar reflections, shadows, things like that. Uses a lot of post-processing effects, especially bloom in some cases. It may use photogrammetry, which requires sort of some type of layered material system. Uses potentially complex particle systems, and maybe minimal UI and text. This is just an example. Now, this type of game and the technical requirements for this type of game is very different to, say, a top-down 3D toon-style tower defense game for tablets. They have different, they have some overlaps, but they have different considerations. So this type of game would require toon visuals, using specific custom shaders. They don't care about PBR features like metallic or smoothness maps and things like this. They may have minimal lighting, especially if you're targeting mobile. So it's one shadow casting global light, maybe some emissive textures. Custom post-processing for unique visuals, unlit toon type particles, and maybe some UI and text. This is just another example. And then if you keep going, you have 2D puzzle game for low-end mobile. Very different design. You have sprites with no lighting, reflections, or shadows. They don't want to add, metallic maps to tiny little cute things that are exploding or something like that. No post-processing effects because they're targeting at performance, and they don't need it. Basic stylized particles, so like some confetti that explodes and things like that, that's not affected by light, and potentially lots of UI and text on the screen. So these three sort of examples are basically showing three different sort of games or game scenarios where you'd factor in a lot of how your scene is rendered or how your game is rendered and the different features that are required. So why is Unity actually implementing these things? So a lot of people who use Unity don't necessarily make the same game, as I said earlier on. They make a whole range of different games. I've seen pretty much every single game sort of fitting into these different categories. So what we want to do is we want to open up Unity so you can kind of gear the render pipeline to your specific game of your choice or your end visual of your choice. So we're trying to make Unity's rendering less of a black box. So you can go in and you can modify certain things. And this gives you more choice on how a game or project is rendered, more customization via exposed parameters and methods. You want to take the skybox and make it like all fuzzy and blurry, you can go ahead and do that. More control over how and where performance resources are used. And this is a key one, especially for mobile, because you don't necessarily want to draw everything on mobile. You want to cut out certain things from the rendering path. So available in Unity 2018.1, sorry, I got a bit cold. We're still having our built-in render pipeline, and that's the current Unity pipeline that we have today and people have been using for years and years. And that has forward and deferred rendering. We're still keeping that. Kind of like whenever we add new systems into Unity, we always kind of keep the existing system, at least for a while, and eventually it'll sort of become legacy. We've got stuff that's like still legacy from like Unity 3.1 or something. So we'll still have that in there, partly for project maintenance and stability. It's what a lot of people use. It's a lot of what people know and things like this. So we're still going to have the built-in render pipeline. What we're adding is an API to create your own scriptable render pipelines. So this sits on top of this, so you can then create your own render pipelines. And we're using that scriptable render pipeline API to create some render pipelines that we're distributing to people. So we're taking that API and we're creating a lightweight render pipeline and a high-definition render pipeline, which we're going to share and you can download today. And the lightweight and HD have very different goals. At a high level, the lightweight one's aimed for mobile, and it's a stripped-back render pipeline that has various exotic lighting features sort of removed so that it can do some faster rendering in terms of lights. And the high-definition render pipeline, which is kind of the other way, we're adding a ton of extra graphical settings and things like planar reflections, decals, shape lights and things, but it's kind of sacrificing performance in some ways, and it's targeting certain shader models. So kind of examples of writing render pipelines for specific goals or feature sets. So sort of giving a bit of a background of the built-in render pipeline. It's the general purpose render pipeline that's available in Unity today. Huge number, it's impossible to say, number of shaders, post-processing, assets, things that are already compatible with it. So two different types of render modes, multi-pass forward and multi-pass deferred, depending on what situation you want. And it was used in Adam and Blacksmith demos, and pretty much all the demos that we released at Unity. So you can do really cool stuff with this render pipeline. Now the trouble is, it's a bit of a black box, sort of tied into sort of how it is rendered and various things. People want to change the lighting. They want to write their own custom stuff on top of it. I've seen people customize Unity in all sorts of crazy ways, not to paraphrase the end of Blade Runner. Yeah, and there's an element of limited control in how the scene is rendered. And you can use things like image effects and command buffers and custom shaders and things to be able to manipulate it, but really people want to go in and write their own stuff. It can be unperformant expensive for some use cases. So yes, you can create something that looks like this, but if you're making just a game with 2D sprite elements, you don't want to factor in and render everything or bring in all these extra exotic features. And some future Unity graphics features won't be supported. So a lot of people come to us and say, we want Unity to be better, and we want you to sort of like throw out the toys and like basically update all your stuff, but we don't want you to change anything. And it's like, well, it's like asking to upgrade a house but keep the kitchen that you've already got is a little tricky. So we're actually building a lot of the future graphics features to support the new render pipelines and make the most and benefit from them, such as decals in HD, which I'll show you a bit later on. So one of the render pipelines we're actually writing, one of the script render pipelines, is the Lightweight Render Pipeline. And you'll see the abbreviation of LWRP, that you'll see that quite a lot in it's just a quicker way of saying it. And this is a stripped back, optimized render pipeline targeted at mobile and VR. And it's kind of built with the ground up, with the intention of doing various things we're at the trade-off of some more exotic things. So because it's for mobile, lights has always sort of been a bit of a problem. You can do forward rendering on lights, but then you have to draw an extra draw an extra pass for each light. Deferred is quite expensive for some mobile platforms. So with this single pass forward rendering system with the lightweight render pipeline, the advantage is you can have up to 8 pixel lights shaded in a single pass. And I'll show you this in a second. So you can have lots of point lights on things moving around, but they're all rendered together. But in the case of this, we sort of remove some more exotic features that stops a lot of these elements being combined. So in this case, some trade-offs are you can only have one real-time shadow light, no point light real-time shadows, which is super expensive for mobile anyway, so you're not kind of going to miss that. No real-time GI, no light cookies, and some post-processing effects, especially ones that require things like motion vectors, such as motion blur, aren't currently supported. And we're looking at how we can add some of these things in, or add in like, it says no SSAO, and I saw a discussion the other day internally of like, okay, we'll make like a lightweight SSAO, like a super fast one to put in there. This is being recorded, so I've just kind of promised something, which, yeah. No pressure. But yeah, so the idea of the lightweight render pipeline is you sacrifice some elements, but then the trade-off is you get some extra benefits out of that. So I'm now going, okay, I've got an extra slide. So when you bring in the lightweight render pipeline package, and I'll show you how to get it, it contains a set of compatible standard shaders, includes an upgrade tool for existing materials. So if you currently use materials using a lot of built-in systems in Unity, so standard shader and things like that, you can actually upgrade these to support this render pipeline, because each render pipeline will require shaders to be configured or tweaked for it. Kind of like when we added like GPU instancing, you have to tweak your shaders to support GPU instancing and things like that. I'll show you how that works. Current unlit shaders like particles, some particles and skybox and things are automatically compatible, which is very nice. And we're building a shader graph node-based system that can generate lightweight render pipeline shaders. And this is going to be a huge benefit as people move over to render pipelines, because they'll be able to generate out shaders from shader graph and then see what the code is that makes it compatible with the render pipelines, which is going to be very, very helpful. And this is a demo being made by a guy called Andre on our QA graphics team. And I think everything here, except the water and the trees, is created using shader graph, which is pretty cool. The water and trees for various technical limitations, but this is basically a demo he's building, and there's a video on our website as well that runs on like mobile as well. So it looks really cool running on mobile with like a light here, and I want to add lights to the boats. That would be super cool, all racing around. So I'm now going to switch to Unity and show you a completely different demo. So what we have here is a very basic scene. This scene has, I've added kind of 6 or 7 lights to this scene, various point lights and spotlights. Some casting shadows, some not casting shadows. And if I go into play mode, you'll see a couple of things moving around. So we've got this like little spider robot guy who's sort of walking around using nav mesh, and you see that like he's casting shadows onto the floor because we've got like a tunnel light, a yellow light above this disk. He's got a little red spotlight. There's like a blue light here, one on the door that's sort of animating. You've got the point lights there. So I try to add lots of different point lights and spotlights, some casting shadows, some not. One of the most interesting things is that the spider robot here is casting a shadow from his spotlight, but then the one at the top, wait, I'll wait until he walks around, is also casting shadows. And wait until he walks. I should make him walk faster, but whatever. Yeah, so lots of things casting shadows. We also have this scrolling here, which is generate like a custom shader as well, but it's unlit. So as we port it, you'll see that it doesn't require upgrading. And if I go to the stats panel, and let's pause it because otherwise it flickers all the time, you notice that there's currently 1,000 batches, which is quite a lot of batches. And we want to get this on iPad or something lower. And you'll notice there's almost 1 million triangles, and there's about 1 million verts as well. And a lot of that comes from lighting. So if I go to my lights, and let's say I turn off my lights, not my reflection probe, because it will look weird. So if my lights, look, it halves basically the number of batches down, and that's just turning off the lights. Oh, that's not even including the light that the spider robot's got. 500, half of our rendering is going into just point lights and spotlights in our scene. And you'll also notice that, yep, that works. I'm also using post-processing as well. So we've got a whole bunch of different post-processing in place. I always like turning off post-processing because it looks hilarious without it. It always looks like really, really like low res, which is super cool. But basically have color grading and bloom and vignette and various other bits and pieces currently in play. So we have this scene with about 1,000 batches. I'm not very happy by this. We need to take these lights and combine them and use a render pipeline that will take them and make them run more performantly. So the way that we can switch, this is currently using the built-in render pipeline, by the way. And I'm going to switch to the lightweight render pipeline. You'll notice that the batch count will drop way down, and it will look pretty much identical. So a new system we're bringing into Unity is this thing called the package manager. We haven't really documented this much, so this is kind of going to be a bit of a segue tutorial. And the package manager is a way that at Unity we can create features and kind of update them into packages into your project quickly. So we hear a lot of people say, oh, hey, we have like, we're using 2017.1. We have to wait like 4 months for like the next big feature and things like this, or wait 4 months for shader graph to add 2 more nodes and things like this. And what Package Manager allows us to do is allows us to update things very quickly, sort of outside of the loop. And I've been at Unity about 5 years, so I'm used to saying, oh, in four months' time, we'll then have the next thing. And it's now like talking to the shader graph team, oh, it's like next week. And I'm like, what? OK, that's kind of weird. And I don't have to download a new version in the editor. That's pretty cool. And what we're doing with Package Manager is we display the packages in your project. If you click all, it will show you all potential packages you can bring in. So you'll notice that a lot of tech that we've acquired recently or we've built, such as Cinemachine, which we acquired, Pro Builder, TextMesh Pro, and Shader Graph we've made ourselves, are all being distributed using this system. So as opposed to going to the asset store, random GitHub repository sitting somewhere, forum post 400 on thread 32 to find some zip of uploaded by someone to get the new version of, I don't know, Cinemachine or something like that. We're trying to consolidate it all in one location, which is really, really cool. And one thing you'll notice is we have here 3 different render pipeline packages. One for core. So this is the core library for the render pipelines for if you want to write your own. One for HD, and one for lightweight. So you'll notice that in this project, I haven't actually installed HD. So if I clicked that, I'll then install the HD render pipeline into my project to use. If I select lightweight, you notice here that it will have lightweight, link to documentation things, and I can update it or view the changes for the update. So I can actually update things very, very quickly outside of kind of the Unity.release loop. Very cool. I've already imported it because I wasn't going to trust the office Wi-Fi, so I've already cheated, so that's fine. So with lightweight, now in our project, I can go to Create, Rendering, and we have this lightweight pipeline asset, and I'll create that. And if I select the lightweight asset, you'll notice that it has a bunch of different graphical settings. Some you're probably familiar with, or some you may not have seen before. And, sorry, I've got gold. You'll notice here we have a couple of sliders for render scale, pixel lights, vertex lighting, depth texture, and things like this. And what we really want to do with these render pipeline assets is expose a lot of settings. So you could actually create like 3 different lightweight assets for like high-end lightweight, which uses like 8-pixel lights, and then mid-range. So you can actually create assets for different graphic settings, which is really cool. And the HD asset is like, it's like, hey, let's add more sliders to Unity because that's what everyone wants. And you can also do things like turn on and off shadows and control this different stuff. So you've now got this asset, and I'm currently still using the built-in render pipeline. I need to set this into the project. I need to say, you now use this asset. I now use this render pipeline. So I go to Edit, Project Settings, and Graphics. And you'll notice here that underneath Graphics, we now have a Scriptable Render Pipeline settings. It's really easy. You just do this really complex thing, which is drag and drop. So you take the asset and you assign it into that. And you do this for the lightweight pipeline, the HD pipeline, custom pipelines, and things like this. So if you wrote your own custom render pipeline, you would expose your own settings and things like that. It's pretty cool. So now when I set it, we now have a completely magenta scene. This is all planned, by the way. Like all the problems are planned. Don't worry. I say nervously. Now, if you were making a game that was entirely magenta, then this is great. You can leave this talk, go away, ship the game. No problem, right? Now, I don't think many people here make games that look like this, so this is a bit of a problem. And that's partly because with render pipelines, you have to kind of tune your shaders or modify your shaders to support specific render pipelines. Kind of like if we release new shader features or graphic functionality, you kind of tune them to fit into, I don't know, GPU instancing for particles or things like that. You'll notice that a couple of the shaders are not render magenta because they're using the unlit shaders like I outlined on the slides. But pretty much the majority of the screen is magenta. Now, if I go to my scene and select something, okay, let's select this tunnel. Actually, there's like a... Okay, so there's like this big round disk on the floor. And what you'll notice is that the material is using the standard shader. And the standard shader is compatible with the built-in render pipeline and not the lightweight one. Now, if I went into my my shader menu in the material inspector, notice that there's a lightweight pipeline menu. So as I said, when you import in the render pipeline, you'll bring in compatible shaders that are tuned for this render pipeline. In this case, particles, standard physically based, simple lighting, terrain, unlit, and things like this. So I could easily switch it and change it, and it would look almost the same. And it'll actually take all the mappings and all the UVs, all the textures in the UV slots, and automatically figure this out, especially if it's transparent and things. Now, I could be really boring and go through like the, I don't know, 50 materials and change them one by one and all the settings. But that's really, that's going to take a long time. So instead, what I'm going to do is I'm going to use a tool that we've developed, which goes Edit, Render Pipeline, and then you see here, Upgrade Project Materials. What this is going to do, it's going to go through your project, find all materials using a standard shader or things like this, or the built-in Unity shaders, and it will like kind of switch it over or sort of port it over to the lightweight equivalent. And it's very, very quick to do this. So if I click this, sure, why not? And then it will change basically all the materials. It did it so fast, partly because I did it this morning, so it's probably cached, maybe. But you'll notice that it then changes all the materials to then use that lightweight version of the standard shader. So you can see here, lightweight, standard. Oh, that was the object I had selected. Let's choose like, I don't know, the floor here, yeah. So it instantly goes in and remaps all the things. Really cool. Now, if I go back to my scene, there's a couple of things that have changed. So post-processing slightly brighter, so you may want to tune it and tweak it. It looks largely the same, would you say, maybe? Almost identical. I did a test internally where I took a screenshot of before and after and tried to say spot the difference to people. And that was interesting, people like going out and analyzing shadows and lines and things like that. But one of the key things that you want to I'm going to point out here is that this pillar, there's no shadow cast off of it. But you remember before, there was a shadow cast off of it. So now if I go into play mode and see the spider robot walk around, there's a flicker that happens just here. So you see that flicker that changed? And that's partly because there's only one real-time shadow supported in the lightweight render pipeline. Typically a directional light for like a sky or something like that. Now, this is good and bad. So you'll notice here it's using this pillar, but when the robot walks here, then it's now using the robot's little spotlight. And this is determined based off of stuff like position from the camera, intensity, things it's affecting, and things like that. Now, what we want to do is we want to determine which one is the shadow we want to use. And we don't want to go through and change all the different settings. So I'm going to use the setting that I hadn't used until I started using the lightweight asset. I've used Unity like 7-8 years or something. And that is this one here. I want to go to, I really like this yellow light and how it casts the shadow on this pillar. So we have this pillar here, and I still want it to cast the shadow. What I could do is actually select the light, go to this render mode here, and I've used Unity about 8 years, and I've never ever opened this before, but now I can. So what this will do is it will set this to be the most important light in the scene, and if I set this to important, we're then determining this is the one real-time light being that's casting a shadow. So if I now click play, we'll then have our robot walking around, scuttling around, and you see it's affected by the shadow. Cool. Now, another thing that I want to point out, because when you switch to different render pipelines, there's going to be a little bit of tweaking and maintenance just to align things up, is that various point lights are being drawn, such as the tunnel, the yellow one above the disk, the one from the spider robot, and this one here. Now, this spotlight's not being drawn. The one that was like here, because in this big area here, wasn't being drawn. And I think there's one on the door that wasn't being drawn. So if I now go to my lightweight asset, you'll notice here that we have a slider for number of pixel lights being drawn. So rather than turning on and off lights, I can actually like scrub up and down and actually determine how many lights are being drawn by the renderer. So you can see here I could actually toggle this up down. So I can toggle this to full. And if I open up the stats window, look here, 387 batches. So rather than 1,000, it's now 387 batches. And if I go, I really like doing this. This is a bit dorky of me, but like, I really like scrubbing through and noticing that the batch count doesn't actually change at all as I add more or less lights. Like, it's only actually when I remove all the lights it like actually changes. So no lights, it's 323 things being drawn, and there's some element of ambient lighting taking place. If I add one, it adds up a bunch, but that's because of the real-time shadow and things like this. So that's currently 387 batches. I add a second one, 387 batches. The third one, you sort of get the point here. Like it's basically drawing all those point lights in sort of one pass or one collection of passes. Really, really cool stuff. So now we have almost a third, not quite a third, it's almost a third of things being drawn on screen, but largely looking the same as well. There's something else I really want to point out, and that's if I go to my post-processing volume here, and we've got different settings like such as bloom and things like that. That's all supported, and you can make things look really, really horrible. I'm terrible post-processing, I'll be honest. And you'll notice here that ambient occlusion. So actually, if you use Unity's post-processing stack, it'll actually say, oh, it doesn't work with the script render pipeline. So it'll not only like not render it, it'll actually tell you kind of what it's not doing and what it is doing as well, which is quite cool. Everyone okay with that so far? Right, I'm going to show you some more cool stuff.
So how do you use ambient occlusion with this render pipeline?
So you'd either have to write your own, or I think you can tweak this to change this to multi-scale volumetric obscurance, and then tweak that. Which, is that even having an effect? Who knows? Okay, let's like crank this everything up. Okay, that seems to have no effect, but yeah, whatever. So we're actually discussing internally, and this is being recorded, so this is, yeah, dangerous. We're discussing internally of like supplying a lightweight ambient occlusion post-processing effect that's like geared for this render pipeline. Because this one's geared to kind of the built-in one, and I think also the HD render pipeline. But it's kind of an expensive thing to do, but you get, it looks really, really good. So that's one thing that we're discussing internally. So yeah. Yeah. So if I now switch back to my slides, which I've prepared. So let's sort of switch things up a bit. So that's kind of lightweight. That's like a sort of entry level for the lightweight render pipeline. There's a lot more cool stuff in it, which I'll show you. Actually, I'll show you now, because why not? So we wrote a blog post called the Lightweight Render Pipeline Optimizing Real-Time Performance. There's a lot of text here, and a lot of this I've already told you about, so that's cool. Upgrade tool, yep, everything's nice. So here we have a comparison chart between the built-in render pipeline and the lightweight render pipeline. So when you're actually using it, I live inside this chart. It's super cool because basically you can go here and see the differences between, directional spot and point is there. You basically get this rundown side by side of what's supported, what's the trade-offs, what's the benefits, and things like that, which is really, really cool. I don't think we've done one for HD yet, but that's a whole nother topic which I'll talk about next. So you can see here in the blog, we've got this whole chart all the way down, and you can see the differences. So let's talk a little bit about the HD render pipelines. This is the other way. So whereas the lightweight one is kind of having trade-offs for better performance, especially when lots of lights are in your scene, this is developed for high-end visuals. It's basically aimed at high-end PCs and consoles, shader model 5 and DX11 and up. It's basically supposed to be like a super high-end rendering thing. Mobile is kind of not the target for this render pipeline. Maybe in the future, but currently not now. Improved and new systems for this render pipeline is lighting, quality, and performance, which you might have seen in the keynote. Extended material settings and inputs. We've added a ton more sliders because people keep asking for that. But for all the settings, camera rendering controls and options, a decal system, which is cool, sort of a volumes system. Debug view modes, which is actually a system which I heard the other day is possibly getting backported, so it will be useful in any render pipeline, not just the HD one, and I'll show you how it works in a second, and many more. And this was actually used for the Book of the Dead Forest demo that we've been playing at GDC and on YouTube and many times into the future. So this demo is built on top of the HD render pipeline, which is really cool. So I don't have this demo, but what I can do is I can show you something cooler. Well, comparatively. So when you create a new project in Unity, what you'll notice is that we now have different templates. So whereas beforehand you made a 2D template or a 3D template, and this would change a bunch of settings in the editor, we now have a couple of extra ones. We have 3D with extras, which basically applies post-processing and all that automatic stuff to make things look shiny on a cube when you first boot up Unity, rather than you bring it and then you have to get post-processing and set it up. It's kind of like that stuff already set up, so cheating. We have the high-end SRP, which when you create this project, it automatically will get the HD render pipeline, set it up, and lighting and things like this. Lightweight, the same on the other way. Lightweight for VR, so I don't really know anything about VR, I'll be honest, but apparently this has got some VR-specific tweaks and changes for lightweight. There's many other VR people wandering around. I'm not the VR guy, unfortunately, so yeah. And no one walked out, so that's a good sign. There's usually always a VR person who's like, oh, great. I do not know. Sorry. Actually, I think the VR team is like one floor up or one floor down. Yeah, somewhere. So yeah, I really don't know anything about VR. I'm sorry.
Mobile VR, which one?
Pardon?
Mobile VR.
Mobile VR. I assume that will be this one. Maybe, yeah. I hope so. I should probably find out at some point. Yeah. I actually don't know how to build for VR, which is yeah. Anyway. And I have that on camera now. So what I'm going to do now is when you actually create that template, or when you're actually going to create that template, it actually builds this project sort of example scene for you. Not this one here, but like a different one. And we put together this example scene, which is both in lightweight and HD, so you can put them side by side with some features enabled. So it's just supposed to be like a bit of a sandbox to see, and the decal system is rendered, just to see how you'd set up a few different elements. Such as lighting and various things like that. So you can actually build this up in HD and build this up in lightweight and put them side by side and see the differences. There's a couple of cool features in HD, and this one's using HD. One is shape lights. So here we have a light. Someone give me a color. Not pink. Oh, come on, man. He was in my shader graph talk, and he said pink every time. Yellow. OK, well, it's kind of already yellow, but I like it. Thank you. Not pink. Come on, dude. I knew you'd do this to me. So what you'll notice here is that the light component has actually been extended using the HD render pipeline, or the scripted render pipeline API. So you can see here enable shadows. You've got a bunch of different settings. You can actually use temperature, intensities, and lumens. You can also do things like affect only the diffuse or affect only the specular. So you can have lights affect only specular on surface, which is pretty cool. You could also do There's also a dimmer setting. So one thing that really annoyed me is that you'd set the intensity to like 8, and then you want to like dim it up and down. You'd have to do it from the value at 8. So now it's sort of split, which as a 8-year Unity user, I'm happy that we finally have that functionality. You can set up shadow settings, and there's a whole bunch of different settings. It's really fun to go through and play around with it. You'll notice that the light has sort of a greater effect when it sort of moves around different edges, especially when I like doing this with the shadows here and with the bucket. Now, one of the cool things you can do here is that you not only get sort of spot, directional point, which everyone's played around with years, but we also get different shape lights. So we have a line light. So if I create this length, you'll notice that we can now do like lights which align, which would be perfect for like sort of ceiling lights and stuff like this. It always kind of weirded me out before, like you'd have something like this, you had to place point lights or do all sorts of weird stuff with it. Although I think everyone's just going to put lightsabers in their games now and get sued by Disney, so no one heard me say that. It's being recorded, so yeah, great. So we can now do line lights as well, which is cool. And you can also do things like rectangular lights. So let me just crank that down a little bit. And crank this up. Pull this up a little bit. And actually rotate this because it's facing the other way. And let's increase the lumens to, I don't know. Yeah, so you can see here that you basically have this kind of rectangular light which you can cast light. So if you have like a floodlight on top of your level, instead of point lights and spotlights and directional lights. So you can do some really cool bits and pieces. And someone actually in the previous session said, could you do curved lights? And I'm like, well, if you take the HD render pipeline and add that, please talk to us, because that would be awesome. Yeah, really, really cool. So lights, we have a couple of extra options. The other really cool thing we've added, which as a long-time Unity user I'm finally doing, happy they're adding, is a decal system. Yay! We finally have it after all this time. And what the decal system will do is it will use a material from the HD render pipeline, kind of like the lightweight one, and it will specifically place decals, kind of using a decal projector system onto surfaces. And you can obviously do like fade scale and things like that. So you see here we have this texture here, and I can move it around, and it'll like automatically will sort of project onto surfaces. You notice here we have this fan using a normal map, and they're also affected by light. So if I place this here, and let's take this one and place this here as well, you'll notice that they're also affected by light, which is cool. If I move this here.
Can you rotate them so that they are cut alongside?
Dude, you're ruining my talk. Come on. Like, I'm joking. Yeah, good sport. Yeah, so we have here, like, yeah, you can basically take the decals, rotate them, and do some cool stuff. You can also scale them. I really like doing this. Like, whoosh. I'm aware there are artists in here who are really angry with me with my lack of artistic skill, but now it looks like an indie game, so yeah. Just do weird stuff. I've learned that that's how indie games are made, I guess. So yeah, now we have a full decal. I was tempted to use the Half-Life 3 logo, but it might not be a good idea. So yeah, you can see we have decals also being affected by light and things like this. Really, really cool. Other things that we've done, so if I now select this, this helmet, which is not swag that we're handing out, unfortunately, you'll notice, like as I said, we have more material settings and properties for the standard shaders and things like that. So we have now, you know, surface types, material type. We've got all these different ones. I'm sure people here know all these names. I don't. Oh, hang on. Displacement, do we want to do different displacement? Do you want it to have a decal projector onto it? You can also do vertex animation via wind for a helmet or trees or whatever. And we have all these different settings all the way down here. So we've really tried to sort of bulk up the number of settings built into our default shaders for this render pipeline. And we've got things like tessellation, layered, especially which is useful for photogrammetry and things like that. Yeah, very cool stuff. Now, one of my favorite tools, which is kind of weird to say because it's not the sexiest of tool, but I think it's awesome, is under the window render pipeline. Hang on, I need some water. The Unity party was last night, so yeah, the thing's a little fuzzy. So it's this debug window. So underneath window, render pipeline, and debug window, we also have this window where we can actually enable, I usually put it here, where you can actually enable and turn on and off different things. So you can actually preview different elements without having to write a script to turn on and off lights or turn on and off this. because it's hooked into the render pipeline via C#, you can then turn things on and off. And you can actually add your own different settings here. And this also not only works in the editor, but it also works at runtime. So if you build your game to a platform, you can actually open up this window on the platform and turn things on and off to see how the normals are interacting or how the lighting is working on device, like let's say a PS4 or something like that. So if I go to actually, let's go to the scene view here and look to a certain area. So you do things like, let's say we want to disable all shadows or enable all shadows, you can do things like that. You can also do material placement. So if I say, oh, I want to view all the baked diffused lighting, check that out. So you can then view all the lighting as itself. So this is kind of an extension of this scene settings here, where you had some settings for different light settings. But instead, we could do things like take this. Let's have a look at all the metallic elements. You notice that there's only a couple in the scene. I'm not going to go through every single one of these because this will take ages and everyone will get really bored. Look at the base color, ambient occlusion. So you can really preview your scene in lots of different ways. We go to lighting and view lots of interesting different elements. Really useful for debugging.
You said you can add some things, so you can add tabs as well. So like you have main camera, material, lighting, rendering, and mic and stuff.
Tabs, extra tabs, I'm not too sure about. I do know that you can say underneath here, previewing the material, you could then like add some extra passes or add some extra material settings. Like that's actually in the keynote that we gave. They actually did that for the Book of the Dead demo because they modified the shaders to do like this kind of like cutout, like you know when light comes through leaves and it visualizes the light's influence through the leaves. Yeah, so they added their own sort of like pass and material settings. So then they like extended it to add that so they could visualize it. So that's possible.
That would be cool. So you could have everything in one place to enable some debugging, not only visuals, but maybe some physics as well.
Yeah, yeah. Oh, that'd be interesting. Well, why would you put physics under this?
Your own custom physics, like some maybe balls rolling out through something, and you can then disable it so you can see how it affects your scene and stuff like that. Like custom
Okay,
things.
if you do that, send me an email. Or send someone at Unity an email. Yeah. Yeah.
I think I can hack my way into this.
Okay, you have that on camera now. Okay, so you get these different debug view settings that you can play around with. I'm roughly sort of running out of time, so I'm going to cut back to here. I definitely recommend going in and playing around with this and seeing all the new things that we're adding. Next one is the custom render pipeline. And this is basically your own script render pipeline. And you use C# API to create your own render pipeline. Custom shaders need to be written specifically for it. And shader graph, actually the slide lies. So shader graph, there will be an API to create your own master node. I don't think there currently is one. Or when I asked the devs, they were like, there is one, but we need to tidy up a little bit. So if you write your own render pipeline, you should be able to write your own master node in shader graph because you can script your own nodes into the system to export shaders to your own render pipeline. That's the goal. And you can start actually, one thing I really recommend is taking Unity's lightweight render pipeline, HD render pipeline, take them from GitHub, branch them, and then start hacking and removing stuff and playing around with it. That's actually one thing I did. I was like, took the lightweight, let's just remove the skybox and remove lighting and go through and actually see how it works. So that's actually something I highly recommend. However, there's also another example. There's a guy who works at Unity called Kajiro Takahashi, and he's in our Tokyo office, and I think he was one of the developers on the post-processing system. And he basically wrote this retro 3D pipeline using the script render pipeline and just put it on GitHub so you can play around with it. So it's a really nice jumping in point at not just a basic render pipeline, but how you can use it to create a certain visual style or visual effect. And yeah, if you actually just search Kajiro, like your life will change because this guy is amazing. So about 3 years ago, he wrote this retro 3D shader, which is the example on the left, which kind of takes low-grade 3D graphics and kind of fuzzies them. And this is very typical of PlayStation 1 and things like that. And what he did is he wrote this like 3 years ago. Oh, my favorite thing is the license. You can use the shader for whatever you want. That's like the coolest license file ever. So he originally wrote this shader. And when we added script to render pipelines, he was like, I'll see if I can turn this into a render pipeline. And then he did. So he basically took that sort of same shader and then tried to modify it and set it into a kind of retro 3D renderer. So this is a really good starting point for sort of dissecting and deciphering how you'd write your own render pipelines for certain visuals. And sort of going back on top of that, oh, let me just show you Kazuro's GitHub. It's amazing. It's like Aladdin's cave. So he has 444 repositories of just so much stuff, and it's all incredible. It's all really cool. He released one recently using the new Unity ECS and C# job system, like this weird little voxel guys dancing around. And he just takes these projects and just sticks them on GitHub, like, hey, have this. And he like churns one out a day or something like that. I'm really happy he works at Unity. Yeah. He's done so much. He's done some really, really cool things. Yeah, compute shaders for. I actually think he did the graphics for the event in Unity. I think he did anyway. Anyway, yeah. So his repository is awesome. And so the point I was trying to make is that he's already kind of written a custom render pipeline, and this is a very good example of writing your own thing to achieve a certain effect. Now, if you weren't feeling as brave as sort of starting from scratch, on the Unity Technologies GitHub, there's the Scriptable Render Pipeline repo. And inside here, you have the Scriptable Render Pipelines, both HD and lightweight. You can actually go in and actually start to modify, change things, and tweak things. You can actually take the render pipelines that we're distributing, like lightweight, and start hacking it, changing it, tweaking it, and deciphering it. My advice is to start with lightweight because HD is significantly more complicated than lightweight, as you've probably realized. So you can go into lightweight and then start to understand the shader library, the data editor, the C# files, and things like that. So yeah, I took it, removed Skybox, and I was like, well, hey, I made my own no Skybox render pipeline. I'm so clever. And really, I commented out one line of code. Yeah, super basic. Another thing that we've done. If you just Google Unity Scriptable Render Pipeline, it's probably like in the top 3 hits, top 3 results. So as well as that lightweight render pipeline blog post, we also have the HD render pipeline blog post, which went up the other day, written by Sébastien Lagarde, who's a awesome graphics god on the graphics team in Paris. And he wrote, this is a really long blog post. I've read probably about half of it, and then it was like then 2 a.m. I was told to go to sleep. And basically, he outlines all the different settings, and basically outlines all the different bits and pieces that are in the HD render pipeline. So if you're really curious on making the most of these things, like you have these really nice bubbles and things like that, and stuff like that, and debug view modes, all this stuff, it's really highly recommended to read this HD render pipeline blog post to see all the new features and get an overview of all the things that are inside it. So yeah, look at all the new settings on the camera. Look at that. Yeah, people want more sliders.
This is new. You just put this up?
Yeah, this is like March 16th, the other day. It's really cool. Yeah, look at all that. Whee! So yeah, if I was to go through all the new HD stuff, it would probably take like 6 hours. It takes too long. You've got this, like some of the demos that we're using it for internally as well, which we'll talk more about in the future, which is really cool. Yeah. And if I go back to my slides. So that's kind of like the big primer of where to begin. Hopefully this is a useful tip of the spear, sort of showing some stuff in the editor and where to begin. It's available in Unity 2018.1, which is currently in beta. We'll start with HD render pipeline and lightweight render pipeline packages, available via Package Manager or under the new project template system. Or they're also on GitHub as well, which is really cool. We have tons of, you go to the blogs, there's like 4 or 5 different SRP blogs, plus also Kazuro's Retro 3D Pipeline, which is a really good starting point as well. We currently have HD render pipeline and lightweight render pipeline. Some people have asked, will you add more? And I guess it's a case of we're going to release these 2, rather than, let's try and release 30 and see what happens. We're going to release these 2 and kind of see the common trends that people want. I'd like to really write a UI-only render pipeline that strips out everything for if you're doing really UI-heavy stuff for low-end mobile or some really cool lighting things. I'm a big fan of Zelda, so I really want to do like a good toon shading render pipeline in the long run. So yeah, that's the general place of where to begin. This is sort of the end of the talk now. If anyone has any questions, feel free to ask me now. I'll be hovering around today and tomorrow as well. So if you want to talk more about SRP, shader graph, general 2D stuff, not VR, because then I'll direct you to someone else. Go for it.
How much heavier is the HD render pipeline as compared to the standard current pipeline?
I think it's more heavier because the current standard built-in render pipeline supports, or is like applicable to, all the platforms that we support, like mobile and things like this. HD is generally not really recommended for mobile, I'll be honest.
Right,
So it is heavier, partly because of the extra things that we're adding into it. So it's really for high-end PC and consoles.
so if I have a PC game and I want to convert it to HD RP, I will feel a performance hit?
Yeah, it depends what you're doing. What they've tried to do with things like lights is kind of try to add the extra functionality, but also kind of, I think Natasha said in the keynote, like also have performance, because lots of games have lots of lights everywhere, right? Well, that's an understatement, but you often have lots of lights for lots of different scenarios or different rooms in your environment. So they've tried to, so it's for the high-end platforms, but they've tried to make it performant to have a lot of stuff on the screen, as like the Forest demo shows. So also performance is kind of a big, there's so many variables on, like, people say, oh, is it more performant or not? No, well, it really depends what you're doing. If you're just rendering a piece of text, then it probably is more expensive, but yeah, it depends what you want to achieve.
Well, my question was basically, will the graph node editor be ported to the old pipeline?
No.
So if I want to use it, I need to use either the low weight or the HD.
Yes. So shader graph basically currently it supports lightweight, and HD is like, it's in a branch of the SRP thing, and then it'll be done hopefully very, very soon. And kind of the purpose of shader graph is it's going to be useful for people to generate shaders that are compatible for the render pipelines. That's kind of a big push towards this, because there is added complexity to the shaders for these render pipelines. But you will technically you'll be able to use shader graph to sort of create your visual effects. I think I showed you yesterday, view the shader graph code generated, and then kind of see like how the code is roughly created. But it's kind of a concept of, we want to support the new render pipelines, this new flow to the future, and shader graph, having it support both the built-in render pipeline, the old render pipeline in Unity, and the new ones is a huge undertaking. So we're trying to future-proof the future. I know it's like their case. People say, we want everything to be better and faster, but don't change anything. And it's like, what do we do? So yeah, currently there is no plans to support built-in, but plans tend to change or stuff. But currently we're focusing on shader graph supporting the lightweight and HD. Actually, some people have tried to use shader graph to generate shaders and then bring them into older versions of Unity and then strip out all the stuff. And I haven't tried that, so I can't say if that works or not. Yeah.
You mentioned consoles, and so if I want to use this render pipelines for Switch, then which one I should use?
I had this exact same conversation with our lead Switch developer like the other day. So I asked him the kind of the same question. He goes, well, so the Switch is generally recommended to be a mobile platform, right? Because it is a tablet that you take and you plug it into output through TV and stuff. So he goes, generally when people ask about performance for the Switch, focus mobile, because that's really what it is for. Now, the trouble is then you want to get all the HD stuff, but it's on mobile. So he said generally lightweight's probably the better one to use for Switch, or the built-in one. Maybe there will be a Switch render pipeline that sort of merges the two, because it's sort of that weird halfway in-between device, if you see what I mean. Yeah. Dude, like, don't say that out loud. Like, you need to go and make this and then make loads of money. So yeah, like, so generally, yeah. I actually think one of the tricky things is a lot of people will build games for like PS4 or Xbox One and high-end PC, and they'll use, like, they say, the HD render pipeline. And then they'll like say, oh, and I'll put it to Switch. And then they've got to make optimizations, but then there's stuff like they've got to remove decals and things like this. So, but they generally have to do that anyway, importing to a low-end device, when games go from console to iPad, they've got to remove stuff anyway, so people are kind of already doing it. Yeah, so I think in terms of Switch, probably focus lightweight and mobile because it is kind of a high-end mobile device, basically. Whereas PS4 and Xbox One, it's HD, but you can use lightweight in everything. Like whereas HD is more HD type stuff, I guess.
So you mentioned that when you're going from like the whatever we have now to the lightweight shader pipeline, you can automatically throw like standard stuff. How do you approach your custom shader transition?
So there's a couple of things. When you click the upgrade button, it'll actually spit out in the console. I should have added a custom shader in there. You actually spit on the console saying this can't be recognized as updated and stuff. So that's another big thing. I know, well, I need to chase the shader graph team about this because it would be a really useful blog post to say, hey, here's an example of a custom shader using these certain things and these certain libraries. This is how you would then, port that from one to one. One really powerful thing is that using shader graph, if you don't want to use a node-based editor, you could still use it to, say, create rim lighting, right? And then you can see the generated shader codes to then see the libraries it uses. And also because you have SRP on GitHub, you can also download the shaders that are used in standard shader and stuff and see the passes they use and the libraries they use. So there's a couple of options. Yeah, I need to, I'll add my email, send me an email, and then I can chase the team to I can ask the team politely because chasing them means something else, right? So asking politely always helps more. So that's my email using the best tool ever, Notepad. It's andyt@unity3d.com. Thankfully, my parents named me that, so it rhymes.
Are the testbed pipelines still there?
I think so, yes.
There's a pipe.
It might be one of these, oh God.
Well, there's no branches. There's like a folder in there that's like testbed pipelines. One of the pipes is taking the standard shader and making it work through SRP.
Oh, okay.
That was in the testbed pipeline. There's some optimizations in there for like tile-based renders like iOS. So if it's still there, that might be useful.
Yeah, it's,
It used to be at the root of the
tests, render loop tests.
there was a folder with the fine prune tiled lighting and there's a couple other things.
Oh, okay. It's probably, I know they've been doing big, because we're kind of geared to, they've been doing big, right, let's trim lots of stuff, but
Branch too, but I'll talk to you after.
hey, if you want to find the branch, be my guest, my friend.
Contributed to it, so.
Oh, okay, right.
It is.
you could just go back and see what you,
Yeah, I mean, let's look at my user.
Yeah. So there's definitely a what's it called? Definitely some kind of tutorial article somewhere in porting. Then you get into the not trouble, but then you get into the big wild west of people writing all sorts of exotic, interesting things in their custom shaders, and it's like, well, this doesn't work for this library that I wrote 5 years ago, and it's like, so yeah, definitely a starting point will be useful. Yeah, cool.
In that current beta version of 18, using the package manager, will it actually install all the information you need so that you can then create projects for the HD render pipeline right now? What you just like when you use the what you call it, the package manager, right?
Yeah.
To install the different stuff. So if you do install the HD pipeline,
Yeah.
and then you go to create a new project, will the release version right now create the project with all the settings that
Oh, I see. So the template where you go in and you choose high end or HD or I can't remember whatever it's called. It changes all the time. That is already pre-set up stuff by our team. So if you say bring in HD into a project like your own platformer project or something like that, and you bring in HD and you set up some settings, that is then specific to that project. In the template system, there are I'm on camera, so that's fine. There are plans to sort of allow people to build their own templates or redistribute packages and things like that. But yeah, the new project, and then you have the high-end template is like the template that we have already pre-set up for people.
Yeah,
Yeah.
I was just wondering if that template is now a stable test bed for
Yes.
with our company, we've been working with that. We weren't able to find it stable enough to
Okay.
work with yet, but that was just 3 weeks ago. It looks like you guys made a lot of progress.
Yeah, it's actually hilarious being subscribed to the SRP repository. There's like 50 new commits every time I wake up. It's like, it's just constantly churning because we have a lot of people putting stuff into it. It is certainly a lot more stable now than it was, say, like a little while ago. I assume as they're sort of ironing out various things. But yeah, it's difficult to say. Yeah. But what they're trying to do is they're trying to make sure that the packages in Package Manager have gone through QA first before they're in there. And same with the templates. So trying to keep everything in sync with what's gone through QA. That's a big part of it. If not, you could always create the new HD template, which already has packages installed and stuff, open up Package Manager and then update it or change the manifest file to a more stable version and things like that. So yeah. Yeah, I know about 3 weeks ago it was slightly out of sync because they were like changing a bunch of things, but it's a lot better now.
Yeah, we're just trying to make the decision to go with the HD pipeline, the standard existing one for a April type release date. So we're like right on the edge.
Oh,
Next
wow.
Not this
April 2019.
Yeah.
Oh, okay. I was just going to say like
kind of progress is being made with
yes. So the 2018 the one's aimed for April, like next month, April as release. So hopefully that will give a better indication, maybe. Yeah. Yep. Cool. I'll be hovering around if anyone has any questions and things like that. I hope you have a fantastic remainder of GDC. There's like, what, 1 day left? It seems like an eternity since this week began, so I'm sure everyone's going to sleep very well on their flights home. So hope everyone has a fantastic rest of the day. Thank you.